In this video, we will see Sawart law. So as of now, we have learned that moving charges will create magnetic field. Now, how can we see moving charges? Moving charges when it is seen in a conductor, that is nothing but a current. Correct. So in a conductor, if charges are moving, we can say that there is an electricity in the conductor. So let's say I have a conductor with a random shape, and out of that I am taking a small element of dl. So it's the same current passing through every part of the conductor. So here the same current I passing through the length dl. So this is the length dl, and this is the direction of current. Now at here, if I want to find the value of magnetic field, I have to apply Sawart. According to Sawart law, you have to connect the current carrying conductor, the element, with the point where you are finding the magnetic field, and this is nothing but position vector R. Okay, so with respect to this current carrying element, we are going to find the value of magnetic field. And Sawart, as per Sawart law, he has proven that the magnetic field at that point, due to the current carrying element, is directly proportional to I. Higher the current, higher will be the magnetic field. Now he has also told magnetic field is directly proportional to the dl. Higher the length of current carrying conductor, magnetic field will be more. So dl. Now magnetic field is inversely proportional to inversely proportional to R square. Inverse square principle. This we have learned in Coulomb's law as well. So higher the distance, lesser will be the magnetic field. So if you are calculating here, magnetic field will be more as compared to the value if you are calculating in between these two points. But if you are calculating here, the magnetic field, it will be higher as compared to this. So this one will be higher compared to this, and this one will be higher as compared to this. So higher the distance, lower will be the magnetic field intensity. Next thing is this, keeping all these things same. Now if you are just changing the position, so let's say dl is in this direction and position vector is in this direction. Now there is an angle created, right? Now when you are increasing the angle to 90, that becomes maximum. But at the same time, when you are decreasing the value to 0, the magnetic field intensity is found to be minimum. Which is that function? At 90, it is maximum. At 0, it is minimum. Sin theta. So sin 0 is equal to 0, sin 90 is equal to 1. So D is directly proportional to sin theta. Now if you are bringing all these things into one equation, D is directly proportional to I dl divided by R square into sin theta. Now Sawart was really impressed with Coulomb's law, where after explaining Q1, Q2 by R square, so F is directly proportional to Q1, Q2 and F is inversely proportional to R square. Later, Coulomb has given the proportionality as 1 by 4 pi epsilon 0. So he has given a similar constant here after doing experiment. So this proportionality has converted into an equation B is equal to a constant. That constant is mu0 by 4 pi into I dl sin theta by R square. So there epsilon 0 was in the denominator, it is here in this case mu0 is in the numerator. So higher the mu0, higher will be the magnetic field at that point. So here mu0 is nothing but ability of a medium to propagate magnetic field, or for the passage of magnetic field lines, how capable the medium is. Higher is the permeability, magnetic field lines can easily pass through that medium. That is the meaning of permeability here. So mu0 is permeability here, epsilon 0 is permittivity here. So this is the Sawart law, mathematical representation for Sawart law. Now B, we know this vector, so it has to be given in vector format, right? So here we know dl is a vector, length is displacement, right? So that is a vector, and even R, position, that is also a vector. How can we connect? So only length and R is the vector here. So how can we connect these two? So this I will change it as D is equal to mu0 divided by 4 pi into I. dl is a vector, R is a vector. So I will do one thing. dl cross R I will make it. Okay, so this will become dl r sin theta. So one r is additional here. So I will keep it in the denominator. R cube. So this is the value of magnetic field. So mu 0 I dl sin theta it is, but this is in vector form. D have to be vector. So here also I should bring vector. So what I can do, I will multiply it with r and r in the numerator and r in the denominator. So dl r sin theta can be written as dl cross r. Open it, dl r sin theta. So one r is additional. So I should keep in the denominator. So r cube and this r will cancel and I will have r square. So this is in the vector form and this one is just we have got the value of Biot-Savart magnitude and this one with magnitude and direction. Now, how to get the direction of magnetic field here? I can apply right hand thumb rule. So keep your thumb in the direction of current. Then, so you can keep your thumb hand in this way, palm in this way. Just rotate it little bit. So right hand in the direction of current and keep this position at your point where you are finding the direction of magnetic field. So here it will be into. Now at the same time, if you are calculating here, direction here. So how to keep this here? Now I have to keep it this way. So this will become my position vector coming out here. So here it will be into. Okay, here when I am keeping my thumb, this direction is towards me. So that is towards me. So here you can see into the plane, here you can see coming on. So in the second lecture I have told you the magnetic field, it will be in a circular way around a current carrying. Okay, make a note of it. Thank you.